Welcome everyone. Today we are going to look at the Get Ready assignment for Chapter 5. There are 3 basic facts or basic skills, I guess you need to know how to do from previous years of math that we're going to be using throughout this chapter. And so this assignment, the purpose of it is just to review those to make sure you know them before we get into the chapter. Video is totally optional. If you would rather just try the assignment and look at the answer key and check your work on your own instead, you can totally do that. You can also feel free to kind of skip ahead to the parts of this video that you need help with, or you can watch it all the way through and do the assignment with me. Totally up to you how you want to do it, but you definitely need to do this Get Ready assignment. Okay, so like I said, 3 basic facts. The first one is pretty straightforward. It's just the fact that for triangles, all interior angles, so that means inside the triangle, always, no matter what kind of triangle you have, they always add up to 180 degrees. So we can use this fact, and we will use it throughout the chapter to find a missing angle in a triangle. So in this example here, let's say we want to find angle X, and we know angle Z is 40 and angle Y is 82 already. All we would have to do, since we know the total is 180, we would take 180 minus the 2 angles we already know, and that's going to tell us what's left over and what must be our measure for angle X. So that would be 58 in this case. So you can go ahead and try these 2 ones. You can pause the video here and then check back. I'm going to do them, so you could do them with me if you want. So in this one, we want to find angle Y. And so we would subtract from 180 since we know that the 3 angles must add up to 180 degrees. And when you do that, you will get, I'm going to type in my calculator, 85 degrees. So I took the total and subtracted the 2 angles I already knew. Okay, this one is slightly different. I just wanted to review the symbol for a 90-degree angle. So a 90-degree angle creates a perfect corner. So typically we wouldn't label 90 degrees, we would use a little square instead. And so this one we want to find angle C, that's the missing one. So I would take 180, the total that they all must add up to. I would subtract the 2 I already knew. And you will get 66 degrees as angle C. Okay, so that's fact number 1. Skill number 2 is using the Pythagorean theorem. So just a quick review of the Pythagorean theorem. It's used only for right triangles, and it's used to calculate a missing side if you already know 2 of them. In the Pythagorean theorem, there are 2 shorter sides on right triangles. These are the 2 that are next to the right angle. And then there is a longer side called the hypotenuse. And that's typically labeled C in the formula. So if you add up the squares of both the smaller sides, you'll get the square of the larger side. So we usually say A squared plus B squared equals C squared. So you can use this theorem when you have a right triangle and you need to find a missing side when you know the other 2. We will use this throughout the chapter, so you need to be very proficient at doing it. And also you should be able to do it in one step. So here's an example. In all 3 of these first examples, we'll be finding the hypotenuse, the longer side, and we're given the 2 shorter sides. So since I know that the square of the longer side is you get that by adding up the square of the 2 shorter sides. If I take the square root, then I'm going to get the measure for angle X. So you can get this all in one line on your calculator. If you do 7 squared plus 12 squared, you'll get 193. Now this is not, 193 is not a perfect square, so it's going to be an approximate value for X. We can round it to 1 decimal place for now. So it's exactly equal to the square root of 193, but it's approximately 13.9 centimeters. So you can pause now and go ahead and try the next 2 on your own, or you can do them with me here. So this one, since we are given the 2 smaller sides, it would be the square root of 10 squared plus 7.5 squared. And that's exactly equal to, so if I do 10 squared plus 7.5 squared, I get 156.25. And this is actually going to be an exact value. If I take the square root of that, I get exactly 12.5 meters. Okay, and the last one here would be 9 squared plus 7 squared. And that is 130. Square root of 130. That's not a perfect square number, so it's going to be an approximate value. You can use a little squiggly equals, or you can use a dot on top of your equals sign, whatever you prefer. And it's approximately 11.4%. Actually, it's meters in this case. You need to look at the units here. So the units on this one are meters. Okay, I'm just going to use the highlighters to highlight my colors here. Okay, what if you are not given the two legs and you are given the hypotenuse instead? Then you would simply, instead of adding, you would just subtract. So let's look at this example here. Let's say we know the hypotenuse, the longest side, and you know it's the hypotenuse because it's always across from the right angle. And let's say you also know one of the legs. So then you would do the hypotenuse squared minus the legs squared, and then take the square root of that. This one happens to work out exactly. When you do 13 squared minus 5 squared, it's 144, which is a perfect square. So sometimes you'll get an exact value, and sometimes you'll get an approximate value. Okay, so for this one, again, you can pause here and try on your own, or you can just do it with me. So it would be 12 squared. This one is the hypotenuse. It's the longest side, and it's right across from the right angle. And this is one of the legs here. So we're going to do the hypotenuse squared minus the leg squared. And that's going to give us the square root of 108. And 108 is not an exact perfect square. So we will get an approximate value, which is about 10.4 centimeters. Yeah. Okay, let's do this one here. So this is the hypotenuse, 26, and 10 is one of the legs. So x would be 26 squared minus 10 squared. Let's use the colors there. This one is a nice perfect square, so we're going to get an exact value. The square root of 576, which is exactly 24 meters. Okay, there we go. So that's the Pythagorean theorem. You should be proficient at that and know how to find a missing side in one step. Okay, now on to the three primary trig ratios. So back in grade 10, we spent an entire unit learning about these ratios and how to use them to calculate missing side lengths and missing angles. Let me just remind you about how we first label a triangle, and then I'll remind you about the three primary trig ratios. Okay, and it all has to do with whatever angle you're looking at. So let's say we're looking at angle A here. So we would label as follows. So the hypotenuse is always still going to be the side that's right across from the right angle. That doesn't change. So we labeled the hypotenuse back when we were doing the Pythagorean theorem. We're also going to label it here. And the other two labels have to do with where angle A is. So the word opposite means directly across from. So we use the word opposite to indicate the side that's directly opposite or directly across from angle A. And then the word adjacent means next to. So the side that's directly next to angle A is called adjacent. We could have also called it next to, but adjacent is one word. So that's how we label them. And then the three trig ratios are just based on these sides. And you can use this little mnemonic device, SOHCAHTOA, to help you remember. So is for sine, ka is for cosine, and t is for tangent or tan. And then the first symbol here, so S indicates sine, and then this would be the opposite. And this would be hypotenuse. So that's how you can remember that sine is opposite over hypotenuse. And then in the next one, ka, you see this is A, that means adjacent, H, that means hypotenuse. So cos of A would be adjacent over hypotenuse. And then finally, tan is O over A, or opposite over adjacent. So you need to be comfortable writing these ratios down in this unit. So let's practice a couple. One thing you can do, you could use these ratios to solve for a missing angle in a right triangle. So let's say we have the following right triangle here, and we don't know the measurement of angle A. So first thing you do is label. So the hypotenuse is always the longest side across from the right angle. So the right angle is there, so there's your hypotenuse. The adjacent side is right next to the angle, and then the opposite side is right across. So the ratio you're going to use depends on which sides you have. So in this case, we have the adjacent side and we have the hypotenuse side. So I would use ka in SOHCAHTOA, or cosine. And cosine is adjacent over hypotenuse, so 6/12. And then when we want to find the angle, we use something called the inverse cosine. And you'll see that on your calculator. Typically, you'll have to press Shift to access it. So find the cosine minus 1 button and type that ratio, 6 divided by 12, and you'll get exactly 60 actually. So sometimes when you calculate, you'll get an exact answer, and sometimes you'll get an approximate answer. It just depends on the triangle you're working with. Okay, let's try this next one here. And you could pause the video here and try these yourself, or you can do them with me. First, we always have to label. So this is the hypotenuse right across from the right angle. This is the opposite. So I want to use sine here because sine is opposite over hypotenuse. So let's write our ratio down. Sine of angle A is opposite, so 9 over hypotenuse, 16. And if I want to calculate angle A, I would use the inverse sine button. In your calculator, some calculators have a fraction, but you can also just type 9 divided by 16. It means the same thing. This one, you're going to get an approximate answer. The inverse sine of 9 over 16 is 34.2 degrees. And this next one, here's angle A. We have the opposite side this time and the adjacent side. So let's use the tan ratio because tan is opposite, so 4.2 over adjacent, 4.2. A would be the inverse tan of 4.2 divided by 4.2, which is actually 1. You're going to get an exact answer this time of 45 degrees. Okay, so that's how you use the sine, cosine, tan ratios, the primary trig ratios, to calculate a missing angle. Now we will review how to calculate a missing side. We always start with the same process that we always label. So in this case here, we're going to be given an angle, and then we're going to be calculating an unknown side. So let's label our sides here. This would be the opposite side, and this would be the hypotenuse. So I want to use the tangent ratio, or sorry, not the tangent, the sine ratio, because sine is opposite over hypotenuse. So I write the ratio like this. And then we simply do, so then we have to look at what we're solving for, x. When the x is in the denominator, we want to use this cross multiply trick. And we can switch the places of the x and the sine 42, and then type that into our calculator, and you'll get approximately 12.0 centimeters. Let's try this. So you could pause the video here and try it on your own, or you can do it with me. Labeling first, this is the opposite side. This is the adjacent side. If I'm talking about that angle, so I want to use tan here, because tan of 57 would be opposite over adjacent, so x over 6. In the case where the number is on the bottom, what you want to do to solve for x is just multiply by that number on both sides, because it cancels it out. So then you're left with x equals 6 times tan of 57 degrees. And we can type that into our calculator. You get approximately 9.2, and it's in meters in this case. Okay, and last one. This one we're going to be using the cosine ratio because we have the adjacent side and we've got the hypotenuse. So cosine, oops, I'm writing the wrong color. Let's change that to blue. Cosine of the angle is adjacent, so 13.2 over the hypotenuse. And this is the one where we have to use that cross multiply trick because the variable's in the denominator. So I switch places. So I type in my calculator 13.2 divided by cosine of 41 degrees, and I get approximately cosine 41, 17.5 centimeters. Okay, and then if you did this by yourself, you can check your work down here as well. The answer key is there. Okay, so that's the end of the review get ready assignment. So 3 skills. You need to know that the angles in a triangle add to 180. You need to know how to use the Pythagorean theorem, and you need to know how to use the 3 primary trig ratios.